This is a video to just review some of the basics behind graphing linear equations. And when we're talking linear equations, we're talking lines, hence linear equations. So there are two forms to linear equations that we will be using. One is slope-intercept, the other is point-slope. But before we get into those forms, just a quick review on slope, which is our rate of change. Now you might see this as rise over run. We could also think this as delta y over delta x, which is the change of y over the change of x. So in this particular example, our rise goes from 2 to 5, so we have a rise of 3. And our run goes from 1 to 3. So the difference in x's is 2. So our slope here would be 3/2. Slope-intercept form gets its name because you are given the slope, so our rate of change, and our y-intercept, which we label as b. So our form is y equals mx plus b. This is the form that most people remember or are comfortable with, although I'd argue that point slope, which we'll go over in a second, is a little bit easier to work with. But if we had an example that was y equals, say, negative 2/3 x plus 4, we would start with our y-intercept of 4, so we'd go to our y-axis and put in our point right at 4. And then we would look at our slope, which is negative 2/3. So our rise, if it's negative 2/3, we're going to be going down 2 spots. So down 1, 2, over 1, 2, 3. And we'd have our spot there. So down 2, over 3. We can go up 2 from our y-intercept and back 1, 2, 3 to get that point. And we'll do our best to create that line. So if it's given in y-intercept, or excuse me, slope-intercept form, and our y-intercept is a nice, easy integer, should be pretty easy to graph based off of the information given. Now, point-slope form may look a little tricky, but it's actually pretty straightforward. And the way I usually like to think of point-slope form, you can see the formula here, y minus y sub 1 equals m times x minus x sub 1 is, I almost like to think of it as blanks. So y minus blank equals blank times x minus blank. Now m, just like before, is still the slope. But if we have another point, say x1, y1, our x value of our coordinate point would be placed in that blank, the y value in this blank. So if we had an example that we were given a slope of 1/2 and a point of 3, 2, our slope, 1/2, would be there. Our x value of 3 would go here. Our y value of 2 would go here. So our equation would look like this. Y minus 2 equals 1/2 x minus 3. So if we're going to graph that, we would put a coordinate point at 3, 2. And then we would use our slope of 1/2. So up 1 over 2, up 1 over 2. We can go down 1, back 2, down 1, back 2. And we have our line here. Just one more example. If we were given y minus 3 equals negative 1/2 x plus 2, if we think about the form that I like to use, y minus blank equals blank times x minus blank, our slope is negative 1/2. That is pretty straightforward. But if we notice, we have a plus 2. And in our form for point slope, it is x minus x sub 1, or x minus blank in my example. So in order to make that a plus 2, that's actually going to have to be a negative 2, because x minus negative 2 would make our value over here plus 2. And since we have y minus blank and we already have y minus 3, we're we're going to put a 3 there. So our point that we're going to use is actually negative 2, 3. So we go over 2, up 3, and then we have a slope of negative 1/2. So down 1, over 2, down 1, over 2, 1, back 2. Some people like to think that it's always the opposite. So if you see a plus 2 there, your point is actually negative 2. If you see a minus 3 there, it's actually a positive 3. Some people like to think of it that way. I personally like to think of it as, what do I need to fill in order for it to be a plus 2? So whichever way works for you.